Hello, this is Mr. Bissonette with another episode of Math in the Classroom. Today we're going to go over the law of sine. So again, since we're using the calculator, we will use the overhead projector and hopefully you can hear everything that we're saying as we run through it. So here we go. So today's learning target, I can use the law of sine to solve for a part of a triangle. Okay, so the law of sine, I have no problem being partial with math because math doesn't care if I'm partial with it or not. This is one of those ones that is kind of one of my favorites. This stems back to law when we were working with sine, cosine, tangent. As a student, I always felt a little bit limited with the sine, cosine, and tangent because it only was for right triangles, and I feel like there's just so many other triangles out there to where, again, it was kind of limiting. That being said, the law of sine is one of those ones that it doesn't matter what kind of triangle it is. It works. So it felt like this was one of those ones where the door was open. Also, a little bit of history of this one for me. My grandma, she was a quilter. When she was alive, she loved sewing, loved building quilts. And if you've looked at quilts at all, one thing you'll notice is there is lots of different triangles that end up coming up. She did really well with kind of the standard normal triangles, but occasionally a pattern would have her creating a different triangle that she was a little at lost. And she would always come up to me and she'd be like, hey, can you help me solve for the length of this triangle? And it was one of those ones that it's like, yeah, no, I can help you with this. So I enjoyed this one quite a bit. All right, so the law of sine looks like this. The way I say it is sine A over A equals the sine B over B, which equals the sine C over C. It's kind of fun to make the emphasis with the capitals, and I think it kind of helps students remember where they go. So the first thing I start out doing, we could have a non-right triangle now with this one. There we go. Beautiful. All right. And let's say this is A, B, and C. And if this is our one, side 2, side 3, just for the time being, I ask students, what side is A? Because a lot of times they mess this part up, and this is a great part to make sure that we have before we get started. A lot of times they will try to say side A is either going to be 1 or 3 in there. They're not completely sure which one it is. It's not any of those. It's actually going to be this side 2, which is going to be our little a. The nice thing about that is we don't have to guess which one it is. It's just that one that is opposite. All right, so that means this is going to be my little b side, and that means this is going to be my little c side. All right, once we have that, now we have most of the pre-knowledge that we need to be able to rock and roll with this. So, back at it again. If we had an example, let's say something like this. Say A, B, C. Let's say this is 110 degrees. Let's say this is 18. And let's say this is, 20 degrees, and this is our x. The way that we use the law of sine will look like this. We're going to say sine of B, which is that 110 degrees, over our 18 equals the sine of A, which is our 20 degrees, over x. Okay? Now, the next example that I give my students, I drop my a, b, and c, and they're like, oh no, which one is which? Okay, it doesn't matter. What the trick is you're remembering essentially this angle. It's going to be the sine of this angle, and underneath it is going to be the side opposite. Sine of this angle, underneath it's going to be the opposite, side opposite underneath of it. Okay. Also, sometimes they'll write this law where they'll switch it, where they'll have little a over sine A equals little b over sine b. Doesn't matter. It still works out just the same. All right, once we have it set up, the next thing we do, or the way that we solve this, is the way, this is one of those ones, those great debates I hear so often. So in some of our curriculum, we have used the Common Core stuff, and I've heard parents say, oh, Common Core is so stupid. I wish they just taught it the way that I learned it. There's parts of Common Core that makes life easier. When that is the case, we'll try to use it. There's parts of Common Core that makes things more difficult. And when that is the case, we'll try to use the old method. So one of the things that it does use and do, and I like it, it kind of simplifies a couple steps, is it says cross products are equal. Cross. So the ones across from each other. Products means multiplying, and we can kind of see that because it kind of makes a giant multiplying sign. And what are they? They are equal. So if we set this up, we'd have x times the sine of 110 degrees equals 18 times the sine of 20 degrees. Now you could use algebra to solve for this, have to multiply by x to get x off the bottom, and then you'd have to multiply by the reciprocal, 18 over sine 110, and it turns out to be the same thing. So again, just saves a few steps. Cross products are equal. There it is. All right. Now currently we have this x, and hanging out, we want this x by itself, and hanging out with it is sine 110. What is the sine 110 doing? Again, products, it's multiplying. All right, what's the opposite of multiplying by sine of 110? Dividing by sine of 110. So x is going to equal 18 times sine of 20 degrees divided by sine of 110 degrees. Once I have that set up, that's when I'll grab my calculator. Excuse me. And we'll simply type it in. 18 times the sine of 20 degrees. You can hit equals if you don't trust it to do the order of operations, and then hit divide by sine of 110 degrees. So now we're going to get x is approximately 6.55. Now notice as soon as we rounded, we switched from the equal sign to the approximately. Again, that's one of those minor details, but I think it's really important to really teach that math in the most correct way possible. All right, that is how we use the law of sine to solve for a missing part of the triangle. Thank you.